off. So we were done with the graph thing, right? I told you that I told you वो पुराना वाला was था. I told you that you've got a thing called an order of reaction. ठीक है, quickly. तो order क्या होता है कि it's the rate of the reaction depends on the concentration of the reactants or the catalyst, and so the rate depends on that, and the power represents the relationship. Okay, how does it actually depend on it? Okay, so the power. So order one meant the rate of the reaction was directly proportional to the concentration of A. So that was what order one was. So if the concentration of the reactant increases, the rate of the reaction increases. During a reaction, so if you use a higher concentration of the reactant, you get a faster reaction. Lower concentration, you get a slower reaction. And if you trace the concentration of the reactant with respect to time, over time the concentration decreases, the reactants get used up. So as it gets used up, the reaction becomes slower and slower. So the gradient becomes less and less. So it takes a longer time for the reaction to finish. Come concentration, it's just going to take a longer and longer time for the reaction to finish. The half-life of this reaction is going to be constant, order 1 key. Order 2 was order 2 meant the rate of the reaction depended too much on the concentration of A. Double karoge concentration, the rate would quadruple. If you triple it, it will become 9 times. If you halve it, it's going to become 1/4. So, तो उसमें क्या होता है कि A की concentration, if it decreases, the reaction slows down by a much bigger amount. So the half-life doubles. Every time the half-life is double the previous half-life. ठीक है, पहली दफा half होने में this is the time required. Second time it's this one. Third time it's this much. So it just takes longer and longer for the reaction to finish because it is slowing down at a very fast pace. और फिर order zero था कि rate does not depend on the reactant concentration. So no matter what the concentration, the rate just remains exactly the same. So if you plot the reactant concentration, it's just going to be a straight line that goes to zero. Reaction start and then it just at the same speed without slowing down, it just ends abruptly when A gets used up. So this was one way of finding the order of the reaction. Okay, now we're going to move to the second method, which is, okay, I'm now going to explain, okay, why do you have order 1, 2, and 3 in the first place? Okay, 0, 1, 2, sorry, 3 तो है ही नहीं course में नहीं है. So, so why do you have different orders? Okay, why is it not just directly proportional or order 0 or order 2, etc.? So order is dependent on the mechanism of the reaction. Or order of a reactant is determined by the reaction mechanism. So most of your reactions, they don't just happen in one go. They've got multiple steps. Organic chemistry, you've studied this in AS, that reactions are not really that straightforward. So I'm going to pick an organic chemistry reaction, which is SN1. SN1 को pick करते हैं, ठीक है? पता नहीं if you remember what SN1 was. This is I mean, it's a halogenoalkane reaction where you had a tertiary halogenoalkane. ठीक है, और उसको मैं explain भी कर दूं. Just a second. भी टाइम है. अच्छा, you had a tertiary halogenoalkane. It had a Cl, and it would react with the OH ions. ठीक है, that was your nucleophile. ठीक है, अगर याद नहीं है ना, doesn't really matter. ठीक है, I'm just explaining everything. I'm just basically writing down a reaction mechanism. So you had OH, and what the OH would do is that it would just replace the Cl. That's it. So your अच्छा, ये जो आपका your halogenoalkane, the OH would replace the Cl and the Cl gets knocked out. ठीक है, that's it. So बस यही होता था, और तो कुछ भी नहीं होता था. Cl got replaced by OH. ठीक है, that's it. It's nucleophilic substitution. Now the mechanism of this specific reaction was कि अच्छा, now the mechanism of this specific reaction was, किसी को याद है क्या होता था? What's the mechanism if you remember this? हमें कोई idea? How did the reaction happen if you remember AS? SN1 में होता था, what would happen was that in a tertiary halogenoalkane, in the first step, the Cl gets knocked out. ठीक है? So your halogenoalkane, ठीक है, तो बिल्कुल जो पहला स्टेप था ना, that was the Cl getting knocked out, and that would form a carbocation. ठीक है, so that's step number one. So due to any number of reasons, a random collision probably. So during a random collision, the Cl is just gets broken away. It just breaks off, and you get this carbocation. That's step number one. Step number two is that this carbocation goes and it bonds with the OH ion. ठीक है, so your carbocation is now free, and your carbocation, it joins with the OH ion. That's it. So it's a simple two-step reaction. ठीक है, पहले step में Cl gets knocked out, and in the second step, the OH comes in and joins with the carbocation. So यहाँ पे I'm going to write this. This is my step number one, and that over here is my step number two. ठीक है, मतलब ये clear है mechanism. ठीक है, अगर ये नहीं भी याद ना, it doesn't really matter. Just remember that you've got this SN1 reaction, and this is the mechanism of this reaction. ठीक है, इसको उठा के इधर रख लेते हैं. ठीक है, अच्छा, तो ये clear है, mechanism clear है. Is this clear? First thing, कि the reaction is
Yes, sir.
happening. It's just happening in two steps. And it could be any random reaction. ठीक है, reactions they don't always happen in just one go. ये नहीं होता कि ये दो डाला तो एकदम से ये बन गया. ठीक है, it doesn't happen that way. First one thing happens, then another thing happens, then maybe a third or fourth thing happens. ठीक है, reactions have many different steps. So इसमें first thing is Cl breaks off, carbocation gets formed, then the OH ion comes in and joins up. अच्छा, so a reaction is like a relay race. ठीक है, कि some Olympics में होता है ना, you got a 100-meter sprint. There are some reactions that are like a 100-meter sprint. They start and they just end. ठीक है, that's it. One step, everything happens. But most reactions, they're like a relay race. ठीक है, first something happens, then something else happens, and so on. Now, how does that relate to order of reaction? वो बीच में कहाँ से है? So what happens is, okay, just like a relay race, you've got many different steps. Okay, so think of this as this is the first runner, then उसके बाद ये खत्म होता है, फिर the second thing starts. So all those runners are not actually running at the same speed. Some of the steps are actually slow. They take a much longer time. Okay, for example, this one is your slow step. And some of the steps are really fast. ठीक है, so they happen very very quickly. इधर ना logic भी बनती है कि like why would the CL break off on its own? There's no reason for it. So you would have to heat it, and maybe during a collision, a CL might break off. ठीक है, so it's going to take a bit of time. ठीक है, so this reaction would be, let's say, or time भी दे देते हैं. Let's say it's taking 100 seconds. So the other one is really fast. Once a carbocation is formed, a positively charged carbocation, it will very quickly attract the negatively charged OH ions. So this reaction probably takes very less time. Okay? So let's say it takes 1 second. This go 1 second, that takes 100 seconds, right? Now remember this, that the whole reaction, the fast step is irrelevant. Okay? Like you have this whole reaction going on. Okay? Think of the whole reaction, step 1, step 2. The entire reaction depends, the speed of the reaction depends on the slow step. ठीक है? For example, अभी कितना time लग रहा है इस पूरे reaction को? It's taking 100 seconds for this one, 1 second for this one. So right now it's taking what, 101 seconds, right? Uh, Fast step is not important. Let's say I double the speed of the fast step. अगर मैं fast step की speed double करता हूँ, now how much time it's going to take? 0.5 seconds, right? So what is my overall time now? It used to be 101 seconds, but now it's 100.5 seconds, right? तो थोड़ा बहुत फर्क पड़ा है. I mean, the reaction has sped up, right? Let's say I increase the speed of the fast step 10 times. If I increase it 10 times, to 1 second, say if it increases 10 times, but let's increase it 100 times, okay? So it's probably going to take 0.01 seconds now, right? So it's very, very fast now. But what has happened to the overall speed of the reaction? 101 se kam okay, it's now 100.01 seconds, right? Acha, but the point is, no matter what you do to the fast step, even if you increase it a lot, the overall speed of the reaction, the change in the overall speed of the reaction is negligible. So the idea is that jo fast step, this fast step, it doesn't really play a lot of role in increasing the overall speed of the reaction. Okay, idea clear hai कि fast step is kind of irrelevant. Is that clear?
Yes, sir.
Sound clear? Sumia clear? Saad, Ahmed, Khadija?
Yes, sir.
अच्छा, तो बस remember कि rate of reaction में your fast step is kind of, I mean, not important. ठीक है, it's kind of irrelevant. इसको million times भी fast कर लो ना, तो it's the reaction will still, I mean, microsecond कर लो, ठीक है? So it's still going to be 100 plus 1 microsecond. So it's still going to be like almost negligible change. So if you want to speed up the reaction, fast step पे मेहनत करने का कोई फायदा नहीं, ठीक है? Fast step is kind of irrelevant. So it's irrelevant in increasing the speed of the reaction. It's irrelevant in increasing speed. And any reactant that's involved in the fast step, that's also irrelevant. उससे कुछ नहीं होना, मतलब for example OH ion concentration, if I increase the concentration of the OH ions, the overall speed of the reaction will kind of remain unaffected. Like if OH ion की concentration, if I increase it like a million times, the fast, I mean, nothing would happen to the slow step, because the OH ion is not doing anything in the slow step. So if I increase the OH ion concentration a million times, the fast step will increase, which would barely have any effect on the overall speed of the reaction. So again, so not only is the fast step irrelevant, any reactant that is present in the, so any reactant present in fast step is irrelevant. कौन सा होता है? Zero order. ठीक है, so this thing over here is important that anyone who's in the fast step, you increase the concentration, the overall speed of the reaction would still kind of remain almost the same. Negligible effect. ठीक है, तो ये क्लियर है खदीजा, ये क्लियर है, साले क्लियर है? अच्छा, एक तो ये हो गया. So basically step number 2, so just remember point number 1, fast step is completely irrelevant, and any reactant that's involved in the fast step, it will not affect the rate of the reaction. ठीक है, so that means it's order 0. ठीक है, order 0 का हमने ही पढ़ा था, it doesn't really affect the speed of the reaction. अच्छा, now slow step is what matters, right? अभी कितना टाइम लग रहा है? 101 seconds. So if I double the speed of the slow step, 50 seconds. So अब कितना टाइम लग रहा है? 51 seconds, right? So now it's really the slow step. Any change in the slow step will affect the overall speed of the reaction. So that's the rate determining step. ठीक है, that's your rate determine. इसी से speed determine होगी. And the rule is that any reactant that's involved in the slow step, and if I double the concentration of this halogenoalkane, then obviously the collisions would double and the time required for the reaction to happen would also 50 seconds ho jayega. So any reactant that's involved in the slow step, the rate of the reaction depends on it. So that means it's order 1, directly proportional. ठीक है, so any reactant involved in slow step is order 1. या आप दूसरा कह सकते हो, the exponent becomes the power. वो मैं बाद में explain करूंगा, ठीक है? Normally it's just so that means you had, अब इस पे now look at the overall reaction, ठीक है? So you had two reactants. You had a halogenoalkane, that was one of your reactants, and you had OH ions, ठीक है? That was your other reactant. ठीक है, ये ऊपर overall equation में you had two reactants, halogenoalkane and the OH ions. So the rate of the reaction is dependent on this reactant, but it is not dependent on this one. तो आपकी जो rate equation होगी ना, that's going to look like this. It's going to be so the rate depends on the halogenoalkane, 3 दफा CH3, then there's a C and then there's a Cl. So it depends on the halogenoalkane concentration, but it does not depend on the OH ion concentration, which is going to be zero order. Zero order लिखने का कोई फायदा नहीं है, क्योंकि anything to the power 0 is 1. So, but you just, I mean, it's better that you show कि it's zero order, ठीक है? So that's how you are able to figure out. अच्छा, तो इसको अच्छा, ये हमने हाईलाइट कर लिया, ठीक है? तो क्लियर आइडिया?
Yes, sir.
अच्छा, अब सारों को क्लियर है? साथ क्लियर है? अहमद क्लियर है?
Yes, sir.
कौन सा खदीजा?
order 1.
हाँ, ऑर्डर 1 ये था ना कि ये तो क्लियर है कि फास्ट स्टेप का कोई काम नहीं है, ये क्लियर है फास्ट स्टेप वाला पार्ट.
Yes, sir.
स्लो स्टेप पे डिपेंड करता है, क्योंकि if I anything that's involved in the slow step, because if I change the concentration of this thing, तो स्लो स्टेप की स्पीड क्या हो जाएगी? वो ज्यादा हो जाएगी, ठीक है? लेट्स से डबल द concentration, the slow 50 seconds ले लेगा. So the overall speed of the reaction will be now much faster. 101 seconds, it's now all of a sudden 51 seconds. 50 इसके, 1 इसके. So that means the rate of the reaction depends on the slow step. तो रेट ऑफ द रिएक्शन तो डिपेंड जब करेगा तो वो क्या होता है, डायरेक्टली प्रोपोर्शनल मींस के डिपेंड्स ऑन इट, ठीक है। रिमेंबर अभी हमने वी हैवंट स्टडीड ऑर्डर 2, ठीक है, अभी वी जस्ट फोकसिंग ऑन ऑर्डर 0 and 1. तो ऑर्डर 0 is के if the reactant is in the fast step, so the rate does not depend on it. And if the reactant is in the slow step, then obviously your rate depends on it. ठीक है, rate depending on it means directly proportional, ठीक है, तो वो ऑर्डर 1 है। खदीजा क्लियर है? 2 के साथ तो कंफ्यूज ही हो गया, 2 I haven't discussed 2 yet, ठीक है, ये क्लियर है?
Yes, sir.
अच्छा, now the question is कि ऑर्डर 2 कहाँ से आता है, ठीक है, that's a question. How do you get order 2? तो ऑर्डर 2 भी बाद में आते हैं, पहले एक और एग्जांपल कर लेते हैं। अच्छा, let's say I've got another reaction. Now this other reaction is there's NO, 2NO, I guess. And this 2NO is reacting with, let's say, Br2. And it's producing 2NOBr. So it's producing 2NOBr. ठीक है, remember I'm just making these mechanisms up. ठीक है, क्यों obviously हम जो mechanism के कोर्स में ना वो तो आपने रट्टा लगाना है एंड में. So I mean these mechanisms, they're kind of irrelevant. ठीक है, it's just a random reaction, and I'm just going to create a random mechanism for this one. So the random mechanism I'm going to come up with is this NO. It comes along, reacts with Br2. So when the reaction happens, so remember this is step number 1. So when the reaction happens, the NO steals one of the Brs from Br2, and one of the Brs gets knocked out. Then another NO comes along, nitrogen oxide, and it reacts with the leftover Br, and you get your complete reaction. Okay, so you get your product, which is again NOBr. Okay, so I just made up a simple mechanism. NO comes along, reacts with Br2, takes one of the Brs, bonds with it. One of the Br is left. That Br goes and reacts with the other NO, and you get 2 NOBrs. Okay, so that's your product. Step 1, step 2. Achha, okay, it's a random mechanism. I just made it up. So I'm just going now. The 2 steps are not going to have the same speed. So let's say the second step is my slow step, and the first step is my fast step. ठीक है, तो मुझे तो पहले तो क्विकली बताओगे रेट किस पे डिपेंड करेगा, विच स्टेप, फास्ट और स्लो?
Slow.
तो ये पड़ा क्योंकि fast is kind of irrelevant. ठीक है, remember that. So just remember, slow step is your rate determining step. So the reaction will speed up. The rate of the reaction will speed up only because of the slow step. The fast step is completely irrelevant. Fast को जितना मर्जी fast करते रहो doesn't make a difference. So that means the rate of the reaction depends on these 2 things. So if I write an equation, so my rate depends on what? It depends on the concentration of NO, and it depends on the concentration of Br. ठीक है, so it depends on these 2 things, जिनको मैं highlight कर लेता हूँ. So it depends on these 2 things. ठीक है, clear हो गया? So I got my orders. ठीक है, so it's order 1 with respect to NO, and it's order 1 with respect to Br. ठीक है, order 1 का मतलब है rate depends on it, directly proportional. अब यहाँ पे एक सेकंड देना, मैं वो चार्जर लगा लो, एक सेकंड रुक लो. अच्छा so वापस पे ये क्लियर है ना ये रेट इक्वेशन ठीक है फिगर आउट द रेट इक्वेशन डिपेंड्स ऑन द स्लो स्टेप रेट डिपेंड्स ऑन NO concentration BR concentration that's it ठीक है क्लियर है यहाँ तक
Yes, sir.
अच्छा अब अगला जो क्वेश्चन क्वेश्चन है कोई ठीक है अच्छा अब यहाँ पे there's an issue the issue is when I say ठीक है now listen carefully when I say that the rate depends on BR right I said that rate depends on BR now we've got a problem because BR is an intermediate the BR wasn't BR I mean this BR over here wasn't present in the original I mean it wasn't your original reactant well it was formed in between the reaction ठीक है like after step number 1 it got formed right so that's an intermediate अब intermediate का ना there's an issue I mean there's no issue over here ठीक है it makes perfect sense but the issue is when I say that rate depends on BR right BR itself depends on other things. When I say rate depends on BR's concentration, right? BR was formed in the previous step. So when I say that rate depends on BR's concentration indirectly depends on NO and BR2 because NO and BR2 are the ones that are making BR, right? So if NO concentration and BR2 concentrations are high, then BR concentration would be high. So when I say that rate depends on BR, I mean this BR over here, then this BR over here indirectly depends on these two. So instead of writing that rate depends on BR over here, which is this one, I'm going to replace BR with, because BR itself was formed by these two things reacting together. So its concentration over here depended on these two concentrations. So I'm going to replace BR with NO and BR2 ठीक है तो मैं फिर एक दफा फिर रिपीट कर रहा हूँ what I just stated was that rate depends on slow step rate depended on NO's concentration and BR's concentration right that's written in red but then I said that this BR was an intermediate it wasn't present in the original reactants so when I say that rate depends on BR's concentration BR itself depends on BR2 and NO BR2 and NO concentration would be high, then BR's concentration is going to be high. So when I say that rate depends on BR, I'm going to cut out BR and I'm going to replace it with NO and BR2 because BR's concentration in fact depends on these two things. So तो ये मैंने किया यहाँ तक clear है? Is this clear what I've done?
Yes, sir.
ठीक है बस सारों को clear ना
Yes, sir.
ठीक है एक सेकंड तो अब इसको जरा just put the things together right so it's going to be rate would be what has happened NO is now appearing twice in the equation ठीक so that would make it NO squared and BR2 is only appearing once so that means so I'm just bringing all the terms together so it's going to be NO squared so that's where order 2 comes in ठीक so remember order 2 is because of the indirect dependence ठीक what order 2 means is कि when I increase the concentration of NO I've got NO over here so that means NO concentration increases that means the slow step speed increases but when I increase the NO's concentration because of NO's concentration BR's concentration also increases so that means because of BR's concentration increasing the slow step increases once more ठीक है तो वो quadratic or squared relationship आ जाती है because when you increase NO's concentration you're not just increasing NO's concentration you're also increasing BR's concentration as well so it's double the effect ठीक है so the reaction if you double the concentration of NO the rate of the reaction will not increase proportionally it will quadruple because it's going to double once because of NO's concentration and because of NO's concentration BR concentration would also increase So the reaction would double once more. So it's going to become 4 times. Okay, so that's where the squared relationship comes in. Okay, तो करना ये है कि you got to keep things simple. Okay, but don't overcomplicate this. Okay, we'll try and keep things simple. Just remember that rate of the reaction depends on the slow step. So it depends on these two. That's it. Okay, so that's your relationship in red. Just don't write intermediates in it. Okay, if you find any intermediate in your rate equation, find out what that intermediate depends on. So don't put Br over here in your because that's an intermediate. Trace and figure out what Br depends on. Okay, so it depends on these two things. So I just cut it out and I replaced it with this, and then I brought all the terms together and I got this. Okay, so that's how I was able to figure out the order of the reaction by looking at the mechanism of the reaction. Okay, is this clear?
Yes, sir.
Yes, sir.
तो ठीक है, एक मैं इसी तरह का ना question, I'll do a slightly more complicated question if hopefully I'm able to find that question. Just a second. पुराने वाले इधर इसमें होगा शायद. इसको भी try कर लेते हैं. Let's try and do this one. You've got this reaction. I don't know what the overall reaction was in this case. Just a second. ठीक है, this is, I mean, for example, just focus on the mechanism, right? So this is your overall equation. H2 and NO are reacting and they're forming water and N2. Okay, that's your overall equation. So what I'm going to do is these are your 3 steps in the reaction. So what if step number 3 is your slow step? मैं वो सोच रहा हूँ कि इसको करना चाहिए कि नहीं करना चाहिए. No, I think we can do that. So what if, although this question he didn't ask for the. So what if the step number 3 is your slow step? So that means the rate of the reaction depends on these two things only. So the rate of the reaction depends on H2 concentration and N2O concentration. That's it. Abajuda, is there an intermediate over here?
N2O.
So N2O is an intermediate, because N2O was formed in the first step over here. So that means when I say that rate depends on N2O, N2O itself depends on NO's concentration and NO's concentration. So I'm going to replace N2O in the equation because N2O itself depends on these two things. So it depends on NO's concentration and again NO's, NO two the far and so it depends on NO's concentration and NO's concentration. I told you that the exponent becomes the coefficient. Although they wrote NO separately, अगर उसको combine करके लिखते ना, they would have written 2NO. So just remember, it's going to make it NO squared. So remember कि जब आप rate equation लिख रहे होते ना, if there's any 2 or 3 any coefficient written, that becomes the power automatically. They decided confusion दूर करने के लिए, they decided to write it separately, but if it had been 2NO, then it would become NO squared automatically. It is becoming NO squared. So that means it's order 2 with respect to NO. It will become NO squared. And this is order 1. ठीक है, ये clear example, this one, if this is the slow step. ठीक है, is this clear?
Yes, sir.
अच्छा, एक और इस तरह का देख लेते हैं कि ये वाला. इसके अंदर बल्कि is I mean, the whole question is about what if step number 1 is the slow step? What if step number 2 is the slow step? What if step number 3 is the slow step? So he's asking for the orders for each one of them. ठीक है? So right now, I mean, the question is assuming that this is the overall equation, and he doesn't know which one is the slow step. So he's trying to figure out the values of A, B, and C. If step number one is the slow step, if step number one is the slow step, तो rate किस पे depend कर रहा है? Only these two things. That's it. So that means rate would depend on H2O2, and it would depend on what's the other one? I minus one. ठीक है? So it would depend on I minus one. That's it. ठीक है? There's no intermediate. अच्छा फिर तो क्या powers होंगी? H2O2 would be power 1, I minus 1 would be power 1, and H plus 1 would be 0 because there is no H plus 1, so that means उसके ऊपर depend ही नहीं कर रहा. So that means over here C would be 0. Is that clear?
Yes, sir.
अच्छा फिर उसने question में कहा what if, तो इसको रब करते हैं, what if step number 2 is the slow step? So let's say step number 2 is the slow step. अच्छा so ये hang हो गया. अच्छा so what if this is the slow step? ठीक है? So rate would depend on these two things. So rate would depend on क्या IO minus 1 and H plus 1. That's it. इसमें कोई intermediate तो नहीं? Is there any intermediate in this? है कि नहीं अहमद साथ?
Yes, sir.
IO minus 1 है, ठीक है? IO minus 1 was formed in the previous step. So when I say rate depends on IO minus 1, indirectly depends on I minus 1 and H2O2. So I'm going to cut out IO minus 1 and replace it with H2O2 and I minus 1. ठीक है? क्योंकि IO minus 1 was an intermediate, and so rate depended on these two things. IO minus 1 को हटा के you write that. ठीक है? Is this clear? तो उसका मतलब है सारों का order 1 होगा in this case. Finally फिर जल्दी से बस तीसरा कर लेते हैं. What if step number 3 is the slow step? So what's going to happen in that case? तो इसको remove कर दो. Step number 3 is the slow step. So that means rate depends on this, and this, right? So that means rate is dependent on HOI. It is dependent on H plus 1. And it's dependent on I minus 1. But HOI is an intermediate. So when I write rate depends on HOI, it in fact depends on H plus 1 and IO minus 1. HOI itself depends on these two things. ठीक है? तो इसको replace कर देते हैं with IO minus 1 and H plus 1. अच्छा फिर so this is my rate equation now. But when I say rate depends on IO minus 1, IO minus 1 itself is an intermediate, and that depends on these two things. तो फिर IO minus 1 intermediate को भी निकालो by and replace it with H2O2 and I minus 1. अब सारी terms को इकट्ठा करो तो what do you get? I think H2O2 comes once. H plus 1 is appearing twice. So that's squared. And I minus 1 is also appearing twice. So that will also be squared. So it's order 2, and order 1. ठीक है? Is this clear? This one, ये last वाला खास तौर पे. Is this clear?
Yes, sir. Yes, sir.
और वो फिर समझ लो कि order 2 का क्या मतलब है कि order 1 पहले H2O2, right? H2O2 को increase करोगे, IO minus 1 will increase, IO minus 1 will increase, so HOI will increase. And because of HOI, अच्छा, because of HY, so only one of the reactant concentration increases. So the reaction is order 1. लेकिन if you increase H+1, तो H+1 की वजह से तो the slow step will increase in speed. But because of H+1, in the previous step, HY concentration would increase, so this reactant concentration would also increase indirectly. So hence the reaction will increase twice in speed. तो वो quadratic square की relationship हो जाएगी. And the same with I-1. Because of I-1, the slow step increases in speed. But because of I-1, I-1 increases, I-1 की वजह से HY increases. So because of I-1, HY also increases in concentration. So reaction will increase because of I-1 and indirectly because of HY concentration would also increase. So तो वो फिर से quadratic relationship हो जाएगी, 2 दफा affect करेगा. ठीक है, तो क्लियर है ये मैकेनिज्म वाला आइडिया? क्लियर है? बस यही है, इसके आगे पीछे कुछ नहीं है, कोई ज्यादा रॉकेट साइंस नहीं है. इज दिस क्लियर?
Yes, sir.
तो
Yes,
चलो
sir.
ठीक है, फिर कल कंटिन्यू करते हैं. बस थर्ड एक मेथड रह गया, दैट वुड बी इट. ठीक है, फिर विल डू पास पेपर क्वेश्चंस रिलेटेड टू दिस. तो कल फिर
Okay, thank you, sir.
चलो ठीक है. ओके, टेक केयर. अल्लाह हाफिज.